Okay, good morning, fourth graders.
Good morning.
Good morning. So today we are going to be multiplying by tens. So we're going to be learning a lot about this, but we are also going to be introducing a new workplace. So we have two learning objectives today. Can I have a volunteer read one of the learning objectives? Yes?
I can solve for the unknown in multiplication and division problems that have no remainders.
Okay, great. Can I get a second volunteer? Yes?
I can use base 10 block scenario models to see patterns, but in most public tests.
Okay, great. So these are the two focuses for today. So far we have explored place value and using place value with base 10 number pieces and linear pieces. We also extended this knowledge of place value to solve area problems as well. So in previous lessons we have discussed again place value using base 10 number linear pieces and number pieces. So we have the units, we have the rods, and we have the flats. So does anyone remember what 1 unit represents? Yes, Lily?
Does it represent 100? Or one unit?
Yeah, 1 unit. What about 1 rod? How many units is in 1 rod? Yes, Stacey?
10 units.
Yes, 10 units. And what about a flat? Yes?
100 units.
Yeah, 100 units. So these are a few things we have already touched on. But before we get into our lesson, we are going to do our noticing and wonderings. So I'm going to give you guys 2 minutes, actually not 2 minutes, I'm going to give you guys a couple minutes to just look at both of these equations and think about a noticing and a wondering. Once everyone has a noticing and a wondering, I want you guys to signal me with a thumbs up, and then we'll talk about them and then we'll write them here. So I'll give you guys as long as you guys need until I see a thumbs up. So everyone has a noticing and a wondering. We're gonna make a list. So would anyone like to share out a noticing they have first? Let's focus on noticings. Yes?
They both have 10 this number.
They both have 10. So both, what's both? They both have what?
10.
Yeah, but what are we talking about? Both what? Both equations?
Oh
Yeah, both equations.
equation.
Yeah. So both equations have what?
Have 10 this
Have 10.
number.
Did anyone else notice that? If you did, can we do a little, yeah? Okay. Does someone else have a different noticing? Yes, Lily?
Both equations have 6.
Both equations have 6. Where do you see 6 in the second equation?
It's 60, but they're both like, what are these?
Numerals?
Numerals.
So you see the 6 in both,
Yeah.
like both, they both have the numeral of 6. Okay, what's another noticing? Yes, Daisy?
They both have different math signals. One is a multiplication, one's a division.
So both equations have, well, each equation is different because one's multiplication, one's division. So 1 multiplication. And 1 division. Okay. Do we have more noticings or are these good? These good? Okay. What about wonderings? Someone have a wondering? Do these problems make you wonder? Leslie?
I wonder why the 10 is always the second number, not the first number.
Oh, that's a great wondering. So, why is the 10 always the second number, you said?
Yep.
Does someone have a response to that? If not, it's completely fine. No? No? Okay. Do we have another wondering? Yessie?
Why do you like choose these two equations? Maybe like they have some relationship?
Okay. So we can say like, do these equations have some a relationship?
Yes.
The equations have a relationship. Okay. Do you have a wondering, Daisy?
No.
No? Okay. Did you see one of these wonderings? Were you thinking about one of these or no?
I was wondering both of them why they have both equations why they have 10.
I have 10. So we can y 10. Okay. So these are great noticings and wonderings, and we'll come back to them at the end of the lesson and possibly answer, if not all of them. Did anyone actually solve the equation or no? Yes, Lily?
6 times 10 is 60.
6 times 10 is 60, okay. And how do you know it would be 60? What makes you say that?
Because when you multiply by 10, you just add a 0 to the number.
So 0 to the number? That's a way you can do it, but what's a different way you could think about this? Or you can help too if you want.
Maybe like you have 6 10 bases. And then, yeah, the total is like 60.
60?
Yeah.
So you're saying like 6 of these?
Yes.
Could you show me?
Yeah. So each one have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So this is 10 base. And we have 6. So 10, 20, 30, 40, 50, 60.
60, would it be 60 units?
Yes.
60 units? Okay. Yes, I can see that. So, yeah, that's a great way to show your thinking. And the reason we don't want to rely on just having a 0, it's because what if we have an equation such as 11 times 10 or 12 times 10? Do you think it'll work? If you try that strategy?
12 times 10. And we just add 1 0.
Yeah, if we just add 1 0. No? Why do you think it wouldn't work? Okay. can keep digging into this further. But a big thing we do not want to do, because it doesn't demonstrate our thinking, is just adding a zero. But it is a good kind of way sometimes, I guess, to think about it, but it doesn't always work. So it's not a strategy we want to pull. Okay, so today, like I said, we're gonna do a new workplace, and then this workplace is called What's Missing Bingo. Has anyone played a similar game to What's Missing Bingo? Possibly bingo? Yeah? Does someone want to explain what bingo is? Not like what's missing bingo, but what bingo in general is. Not, it's completely fine. Yes, Daisy?
It's like you have like a set of numbers, and then someone calls out a specific number, and you just wait until one of the selected numbers is on your card.
And then you like put an X.
You put an X.
Yeah, that's a great explanation. And that is generally what bingo is. The only difference with our bingo is instead of just drawing out numbers or letters, we're gonna be drawing out equations. And before we can mark an X on our equations, for example, like this equation, we have to figure out the missing value, and whatever the missing value is, we essentially, if we have it, we can mark it down on our bingo card. So let's say, I don't know, the missing value was, what do we think it's here? 2? 2. If we have 2 on our bingo sheet, like right here, we would mark an X. So we're gonna do this collaboratively. I'm gonna be joining you guys as well. And I just want you guys to remember that this game is about working together and finding the missing value together, and it's not essentially about winning. I know that could be like very motivating, but I feel like it's much more motivating to get these strategies or like the ways we think out. So I'm gonna pass out a bingo sheet to everyone. And we're just gonna do a couple rounds before we get into our actual lesson. And then we're gonna continue this for a couple rounds, like I said, but to have a winner, we need to have 4 in a row. That could be diagonal, vertical, or horizontally in order to be considered a winner. But as you guys can see, it's a little bit different from bingo because we have like equation lines. So each time we draw one, we write it down, and then we write the missing value down. We just continue to write it down. So, I feel like it'd be beneficial if you guys took out a pencil or a pen. You're welcome. Let me get a pen. Oh, and I forgot to mention, we also have 100 frames in case you guys would like to show your thinking on this. You guys don't have to use these, but it's just as a support tool if you guys want to use it. Okay, so we're each gonna take turns drawing one. We would like to draw the first number equation out. Okay, I'm just gonna. Okay, I saw your hand first. Okay, we have 7 times blank equals 35. Let's think about it a little bit. Who has an answer to that? Do we all have an answer? Okay. What's your answer?
5.
What's your answer, Daisy?
5.
5. So we all agree it's 5. Okay. And how did you guys think about this? Or like, is it just a fact you guys know?
Yeah, I feel like it's just a fact for me, and yeah.
A fact? Okay. It's fact as well? Okay. So we're gonna write 7 times, what was the missing value?
5.
5 equals 35. Do I have a 5? Yes. Does anyone else have a 5?
Yeah.
Okay, great. Okay. Lily? "16 divided by blank is 8. What do we think it is?
I think it might be 2.
2? And why do you think it'd be 2?
Because I was thinking division is the opposite multiplication.
Mhm.
So 8 times something has to give me 16.
Oh, okay.
So 8 plus 8, 16.
Mhm.
So it has to be 8 times 2, 16.
Because you added, so you did 8 plus 8, you added it twice, so that's why you did 8 times 2. Okay, so, okay, that's good. So Lily thinks it's 2. Do we agree with the number 2?
Yes.
Did we think about it the same or differently? The same?
Yes.
Okay. I have a 2. Okay. Do you want to draw one, Daisy?
I have something times 7 equal 7 times something equals 14.
14. Okay. Just think about it. Does someone have an answer? Or are we still thinking? I like how you're using your 100 frame. This is great. Do we have an answer?
Yeah.
Can we show it with our fingers? What do we think? Oh, we all think 2.
Yeah.
And that was my only 2. Was that the same for you guys, the only 2?
I have another 2.
Oh. Is someone close to winning? No?
No.
Same. Okay, I'm gonna do 1 more or 2 more. Okay, I have 6 times blank is 54. So I'm gonna write it down first. Does someone have an answer to this equation? If not, it's completely fine. It's 9? How did you get 9, Daisy?
It came quickly to me.
Quickly? Do we agree it's 9? Yeah? Why do we agree it's 9? How did you guys think about it?
For me, I thought about how we said that 6 times 10 earlier was 60. So then I know that if I take 6 away from 60, it gives me 54. So it has to be less, so it's gonna be 9. No.
Okay. Yeah, that's a great way to think about it too. So we have 2 different strategies and we combine them and they both give us 9.
Mm.
Yeah. So 9. And I have 9. Oh, I have 2 9s. Which one's gonna help me? Okay. Remember, it's not about winning. Okay. Should we do one more?
Yes.
Okay. Do you guys want me to choose it? Okay. Maybe it's a winning ticket. 5 times blank is 30. Do you have an answer, Lily? 6. 6? What about you, Daisy? Do you have the answer?
I also think it's 6.
Shane, do you think it's 6?
Yeah.
6? Okay. Can you share why you think it's 6?
So I know 5 times 5 is 25, but I need to get 30. So I try like 5 times 6, and it's equal 30.
Equals 30?
Yeah.
So you added 25 and to get to 30, you possibly added another group of 5, so you did 25 plus 5?
Yeah.
And then that's what you got. Okay. 5 times 6 is 30. Did we all have a 6?
Yeah.
Okay. Well, we're gonna pause here and then we possibly might get to it at the end. Okay, now we can just keep our paper sheets. Now we're gonna transition to Finn's problem. So I'm gonna pass out Finn's problem, the worksheet.
I can do it.
You wanna pass it out? Okay. There you go. Thank you. Okay, so here we have Finn's problem. Could I have a volunteer read the problem out, or like the context? Yes, Daisy?
Finn needs 90 square centimeters of cloth to make a patch for Springfield Rec Center. Staff will wear the patch on their skirts or hats so everyone knows how to go for help. Finn cut a rectangle of cloth, and that was 6 meters by 10 meters. Was that enough?
I don't know. So it's centimeters, right?
Centimeters.
What could be the patch that Finn is making? This is just like what we think. What do you guys think Finn is making? Like what type of patch? Like design. Like what do you guys think he's gonna design?
I think it might be like a little logo with the company name, the Springfield Rec Centers.
Okay. Any other ideas?
I think he'll make a print.
Okay, okay. Do you have an idea?
No.
No? It's okay. Okay, so what is this problem asking us to do, and what information will we need to solve it are 2 questions we are going to think about together, except me, like you guys, as a group. And then we're going to come back and then write them down on my iPad. So I'm going to write your guys' ideas down. So I'm going to give you guys 2 minutes to talk about both questions.
for him to cut a rectangle of cloth that's like 6 centimeters by 10 centimeters. What information will we need to solve it? So
I think we need to use the 90.
agree.
Because that's how much he has to cut.
Mm-hmm.
So whatever he cuts has to equal that. But it says here that he only cut 6
Six.
centimeters
By 10 centimeters.
So we can use those numbers too.
Yeah, so we will use 90, 6, and 10.
Yes, to see what the difference is between both cloths, what he cut and what he needs.
I agree.
Now we need to solve the problem.
No, just A and B for right now. If you guys are ready, just give a thumbs up. Okay. So, what is the problem asking us to do? I can write it down. What did we talk with our group about?
We were asking like what is the problem asking us to do, and we also shared like what information is needed in order to solve the problem.
And what did we say for what is the problem asking us to do?
The problem is asking us like if the measurements of the 6 by 10 meters will be enough for the 90 square centimeters of cloth.
Okay, so is the 6 by 10 centimeters enough? Enough for what?
To make the cut.
For making a patch.
And how big? Oh wait. What information will we need to solve it? Yes?
So we talked about there are 3 numbers in this question, and there are 90, 6 centimeters by centimeters. So we think we need to use these numbers to help us solve this problem.
Okay. So use numbers in equation to solve problem. And does someone know what problem we can form to solve the question? To solve what the problem is asking us to do? Yes, Lily?
I don't know if it's right, but can we do 90? Well, 90 equals the amount he needs, so then can we do 6 times 10 to show whether that equation is equal to what he needs or not?
So you're saying 6 times 10 and then
Compare.
could equal, or
Like, it's supposed to equal 90, but it doesn't. So is there a way that we can show?
like this, maybe?
Yeah.
Oh, here.
Or maybe we can do equal 60 but not equal to 90.
How do we know it's 60?
6, 10 bases, so it's 16. 60.
Here, I'll write it like this right now. So you're talking about these basically.
Yes.
We're gonna use this actually to solve if 60 by 10 centimeters. So 6 centimeters by 10 is enough. We have our flats, which are how many units? 100. We have our rods, which are how many units?
10.
10. And then we have our units that are
1 unit.
1 unit. Okay, so using these materials, I want you guys to give me a model of 6 centimeters by 10 centimeters. So feel free to use any. So what does this model represent? Where is the 6?
The 6 is up here, so it's 1, 2, 3, 4, 5, 6. Okay, so 6 lines, and those lines have 10 units each. So then when you do all the 10s and all the 6s, it gives you 64 units.
So I saw you said 60 lines. What's another 60? You said 6 lines, right? What's another word for lines?
Rods,
These are rods, yeah, but like when we have, so you had it like this, right?
Mhm.
So we have 6 exit lines. What are these called? It's okay. What about these? Yeah, I'll show you. I'll give you a little push. So lines are
Column.
columns. Yeah. That's like the math word. And then these would be
columns,
these are columns.
Line. Rows.
Yeah. So instead of 6 lines, there's 6.
columns.
And then where's the 10 here?
Here, there's 10 rows of 6 and 6 columns of 10.
Okay. And you said it equals 60, right?
Yes.
And how did you get 60 again? Did you just
Because when you see, like, when you count over here, there's 10, so you do 10, 20, 30, 40, 50, and 60.
okay. And is that 90?
No.
No, right? Okay. Should I see your models?
Yeah.
So is your model like this or like this?
This.
Yeah?
Yeah.
Okay. So where is the number 6 represented on here?
So each of this is 10. So it's 10 base. So I have 6 of the 10 base. So 10, 20, 30, 40, 50, 60.
And then where is the 6 again?
1, 2, 3, 4, 5, 6.
And what if you keep it like this? Where is the 6 without like moving it?
1
Without moving it?
without moving.
Yeah.
1, 2, 3, 4, 5, 6.
So 6 straight down, right?
Yeah.
Okay, so 3, 6. And then where's the 10?
This one is 10.
Do you, 10, So then it's 6 by 10, right?
Yeah.
Is that where you have your 6 and 10?
Yes.
Okay. So what did we get for our array model? What's the answer? Total units.
60.
60. And then the problem, we needed how many square centimeters?
90.
90. So, was that too much? Or was that just not enough?
Not enough.
Not enough?
Yeah.
And how much more do we need then? How could we solve for that? Yes, Daisy?
We can subtract the larger number versus the smaller number, and that will give us our remaining number.
So the larger number is
90.
90. And then subtract by 60 is, what would that be? 90 minus 60.
30.
30? And is this what you were gonna say earlier? Yeah. Were you gonna say the exact same thing? So we kind of answered B already. Did Ben cut a big enough piece of cloth? If not, how much more cloth is needed? So how much more cloth did we say he needed?
30 more centimeters.
30 square centimeters. Okay. Now that we know that 6 centimeters by 10 centimeters is not enough, I want us to look at questions 2 and 3, first at 2, where we have to list all the possible dimensions for the patch, for his actual patch, for like the 90 centimeters squared. So just think of different ways we can make this type of patch, and then for number 3, what dimensions do you think would be best for the patch? It's more of your opinion of what you think would be, again, the best dimensions for the patch. So we're gonna work together collaboratively to solve both of these remaining questions. Technical difficulties, y'all. But then we'll come back. And you guys are free to use these, the array, the base 10 pieces if needed. I actually encourage it, but yeah.
We're doing this collaboratively.
Collaboratively.
I think 1 can be 9 times 10.
Yeah,
times
I agree. 9 times 10. Maybe also 45 times 2. This one, 3 times 30. Maybe also 5 times 80.
So I like how you're thinking about these in your head. Is there a way you can use the base 10? once we think we have all the dimensions possible, we can touch our heads. Okay, and then give a pat on our back because that's such a great job. As I was walking around, very great job. Okay, so now we're gonna list a couple. Actually, we're gonna list all the dimensions that we need with this. If this doesn't work, that is completely fine because I also have a copy. Which I can make it. Okay. So, what's one possible dimension that we had for this rectangle? Yes?
9 times 10.
9 times 10. Were you gonna say the same thing or different? So 9.
Does he have a question?
Yes.
Would it be the same if I said 10 times 9?
10 times 9.
Would
Yeah,
you
that
flip them? Would that be different dimensions?
it would give the same 90 square centimeters, but it's a great question. But the difference would be the way it'll appear. But let's see actually. So you said 10 by 9? So 10 by 9 is 10 rows. 10 rows of 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's how 10 by 9 looks. Now we're going to do 9 by 10. So this one would be, instead of 10 rows, 10 rows, it'd be 9 rows. So 3, 6, 7, 8, 9. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows. And this one would be 9 rows.
I have a question. If
Yes.
this is 10 rows, right?
Mhm.
It should be 100.
Yeah. My bad. Yeah, you are completely right. Sorry, I'm thinking about this a little wrong. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9. I'm gonna take these. 3, 6, 7, 8, 9. Okay. 3, 6, 8, 9. 6. So, do we think they look the same? I mean, like, what do we think? So this is 10 by 9. This is, just make sure I have it right. This is, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Maybe
10, 9, 9, 10. There we go. Okay. Sorry, it's like they're so close in number that they confuse me. So I'm gonna put them a little bit closer together, and I want you guys to just look at them and if you have anything to say, you can say it.
I think they look like 2 different dimensions.
Yeah.
Because this one is longer. This one is longer. Width-wise, but the other one is longer. Length-wise.
Lengthwise, so height.
Yeah, that one has more height, and this one's more width.
More width. Yeah, width and then height. So width and then height. Were you gonna say the same thing?
Yes.
Yeah. What about you, Daisy? What do you think?
The same thing.
The same thing. Isn't that crazy?
Yeah. So strange.
Because I know we talked a lot about how 9 times 10 and 10 times 9 is the same thing. But when we like have it in front of us, it kind of is not the same thing. Like use our base 10 pieces and make like an array table.
Yeah.
Okay. Do you guys think I should write both dimensions then?
Yes.
Yeah. So it'd be 9 centimeters by 10 centimeters. And then 10 centimeters by 9. Okay, are there any other possible dimensions that we came up with?
You also say maybe 3 times 30 equals 90.
3 times 30.
Yeah, because like we just talked about that situation, maybe 30 times 3 equal 90 also can count for this question.
30 centimeters by 3, right?
Yes.
And then the exact same thing, 30 centimeters by 3, 30 centimeters by 3. So do we think that's gonna work out for all the dimensions that we list? Like just flip them around?
Yeah.
No? Okay. Do you guys have any more dimensions? No? There's a couple more. Do you guys, I'm gonna give you guys 1 to 2 minutes more to just think more about other possible solutions or other possible dimensions. There's still a couple more. I think if we have like just 2 more, that would be great.
We said 45 by 2.
45 by 2. Okay. How do you know 45 centimeters by 2 centimeters is 90?
Because every multiple.
Yeah.
Every multiple of 2 is always an even number. So 90 goes into. So 2 goes into 90 45 times. So
2 goes into 90 45 times. Okay.
I think also like 50 and 50, but like we have 45 times 2, so I get rid of 10, so it's 90.
So what would the equation, the
I say, what was I say? 50 times 2,
15 times 2?
yeah, equal 100. Oh no,
50 times 2 is 100?
50 times 2,
Is 100.
yeah, 100, but like we need 45 times 2, so I just get rid of like 10.
Oh, okay, that's smart too. I like, so you're going to, what is that, benchmark numbers kind of in a way? With like the 10 stuff, and 50 is like kind of similar to 10, benchmark, okay. That is a great way to do it too. One more dimension. Let's think about one more dimension.
15 times 6.
15 times 6?
Yes.
Oh, how did you think about that quickly? Here, I'm gonna do something. Since I noticed you didn't use the base 10 blocks to get the 15 times 6, I wonder if maybe you can demonstrate your thinking on a whiteboard.
So 15, I said 15 times 6 equal 90. So I just divide 15 to 3 times 5 times 6. 6 I also divide by 2 and 3. And I feel like and divide this maybe. So this 5 times 6 equal 30,
Mhm.
and I have 330, and so this is 60, and I add 30, so it's 90.
90. Wow. So you broke all of this in your head.
Yeah.
And what I noticed here, wait, see the marker, please? Actually, it is different. What I noticed here, besides like the breaking down, I noticed that we got back to the 30s, and then our sheet we wrote 30 times what equals 90.
Oh, sorry.
3. Isn't that funny? We have 3 groups here. So basically, you did 30 times 3.
Yes.
So what we did.
Yeah.
But I like how you broke this down. It's really good. Okay. So we can write 15 times 6 if we don't have that down. Actually, not 15 times 6. Right now we're just writing a dimension, so it'd be 15 centimeters by 6 centimeters. But in equation form, how you guys were thinking,
15 times 6
it would be 15 times 6.
or 90.
So all of these equal 90. Wow. Out of all these dimensions that we came up with, what dimension do you think would be ideal for the patch? So we can like think back to the context to answer this question. But yeah, so what patch would be the best? Which dimensions would be best for the patch? So I'm gonna give you guys 2 minutes. Oh, well you can share out in a bit, actually. Let's write it down first. Let's give our groupings a little bit more time to jot their thinking. Once you have something down, like you're thinking of, we can raise our left hand up in the air. Okay, left hand, good job. So, who would like to share out first? Yes, Lily?
I think 9 by 10 would be the best because it's the most proportional. I think
I like that word proportional.
we're making it for cloth or for like clothes, so shirts and hats. I feel like if we have like a 45 by 2, it's gonna be way too long and way too thin. But I feel like having a 9 by 10 is just like pretty good rectangle that fits most items that he wants to.
Yes.
Also, like the question said, think as rectangular of cloth that was 6 centimeters by 10 centimeters. So I feel like definitely maybe there's a 10, and that's like much more appropriate.
So did you say the same dimensions as Lily? Yeah. And could anyone restate what Lily said about like the 45 by 2? Why did she say that again? So what did she say about 45 by 2? Why wouldn't she pick that one? It's okay. Do you want to explain again why you wouldn't pick?
Yeah, so 45 by 2 is just gonna be way too long and way too thin. So on clothes, I feel like that wouldn't make the most sense just because I feel like at that point it's not a patch anymore. It's more of like a, I don't know, a really long piece that goes around clothes.
Like a seatbelt.
Yeah,
No way.
so I feel like this rectangle shape is just the right amount of space that he needs to centimeters.
It's a great reasoning behind your choice. Did we write all of our reasonings down on our paper? Oh no. I'm gonna try this one more time. And now, because now we're gonna move on to one more worksheet. And if it doesn't work, that is completely fine. Hold on. I didn't take the worksheets out. So we're going to be working on Finn's flyer. We can put our names on it and the date while I set up my tablet. We can also read the problem to ourselves and like think about it. Okay, so Finn's problem crossed out, and now we're in Finn's flyer. Okay, so we're gonna read the page together. Can I get a volunteer to read the first half of it? Yes.
Finn is planning to make a flyer for the Springfield Rec Center that is exactly 240 square centimeters. Here are the dimensions of 4 rectangular pieces of paper Finn found in the art room. Help Finn figure out whether any of them will work. 10 centimeter by 8 centimeter, 10 centimeter by 12 centimeter, 10 centimeter by 50 centimeter, 10 centimeter by 23 centimeter.
So they give us a list of dimensions that could possibly be 240 centimeters. Which of these rectangular dimensions could possibly work? So I'm gonna give you guys 2 minutes to circle the one you guys think would be the closest to 240 centimeters. You just have to circle one. Okay. Does everyone have one circled?
Yeah.
Okay. Do you guys want to share out which one you guys circled? You don't have to explain. You can just
I said 10 centimeters by 230 centimeters would work best.
Okay. What would you say?
Yeah, I also choose 10 centimeters by 23 centimeters.
Would you say the same? The same? Okay. So 10 centimeters by 23. So now we are going to test out all the dimensions using the base 10 pieces, but before that, if it doesn't die, instead of showing it on here, we're going to use this special app. Disconnect. So the first, who can read me the first dimension? Yes, Lily?
10 centimeters by 8 centimeters.
10 centimeters by 8 centimeters. Okay, who wants it demonstrated on here? Here. I'm just gonna show you guys really quick what we can do. We have the flats, we have the rods, and we have the units. So essentially it's the same thing, just virtually so everyone can see. So since you read the first one, do you want to show the model for this? Oh yeah, you can take it off. So many rods.
I did it a little bit different.
Okay.
So
Could you explain?
I did 7 columns
Mhm.
of 10 rows. Well, no, I did 7 columns of 10 because that's 70. And then I did 1 row of 10
Of 10?
just to be different and use my units as well because 10 units make up 1 hour.
That's great. So this is all how many in total? Units? 80? Okay. I feel like that's great, but remember we have to find a rectangular shape. Would you say this shape is a rectangle?
No.
So what would you have to do?
I would have to take these out and replace them with 1 more rod.
Also,
So
yeah, we don't have to like, when we have 10 units, we can just replace it with, like you said, a rod. Yeah. So this, 1, 2, 3. That's okay. So we have 3, 6, 7, 8, 8, 10. We have 8 here, and then we have 10 here. So does this look like 240 centimeters? No. How many would this be?
80.
80. Do you agree, Daisy?
Yes.
Okay. Now we're gonna move on to the next one. Who could read the next dimension?
10 centimeters by 12.
10 centimeters by 12. Okay. So now it's gonna be your turn, then you're gonna show you would do this. And then you can also talk about it as long as you demonstrate your model. So how many rods are you thinking of getting, Daisy?
10.
10? You can just remove or have one.
This is my thought process.
So what is part of your model? Is all of this part of your model?
Yes.
Okay. So could you explain it a little bit to the class?
So I counted 10 of these rows.
Mhm.
So I counted like 12.
So the rods?
12 rods.
12 12 rods. And what about these?
I just missed counting, so I started over again.
Oh, okay. So we're working in here, right? And could you label the dimensions? And what else could we add to these dimensions? Why did I do that? Was it like that the whole time? Oh, no. Okay. Well, we have a 12 on this side and we have a 10, right? Okay. What's missing? What else can we add to the dimensions? We have the numbers, but what else can we add to both dimensions? What's the units?
Squared centimeters.
Square centimeters. So we can add square centimeters. Yep. Okay, that's great. Okay, so essentially it'd be 10, hold on guys, 10 square centimeters. A lot of square. 10 square centimeters by 12 square centimeters. Okay. So I noticed you used all rods. Maybe there's a different way we could think about it. Does someone else have a different way they thought about this one? Okay, I'm just gonna refresh it, okay? So I noticed you did all rods to do 10 by 12. Is there a different way we can do this? Yes, Lou?
It would be good to use a flat.
A flat? And then what else would we need for the flat?
Add 2 rods, so it's 12 rows of 10.
12 rows 10. Can you show this? And would that give you the exact same answer as the other one? Yeah. So instead of using a flat, instead of using rods, you did a flat. And how did you know to do a flat?
Because a flat is 10 rows of 10, so then it gives me 100 total. So then I know that I have 10 rows here, and since it's 12, I just need to add 2.
And essentially you're saying Daisy had this, right? But she could also use a flat. Okay. So since my tablet is charging, we're not gonna do the following on the tablet. We're just gonna continue our thought process with the manipulatives. So who can read the next dimension? Yes?
10 centimeter by 15 centimeter.
Okay, do you wanna show that? 10 centimeters by 15. We need all tools. And remember, we have to label our units. Okay, can you explain?
So, this is 100 and here are like 50 and it's like the total is 150.
150.
Mm-hmm.
I'm gonna bring your model to the middle. So this length is
10 centimeter.
10 centimeters. centimeters.
Square.
And then this length is, actually you're right, 10 centimeters. Square centimeters, yeah. No, 10 centimeters, there you go. The final answer would be square centimeters. And then this one is
50.
15, okay. And you said it's 150?
Yeah.
Do we all agree with 150? Should I take my time and count every single? No, I don't, okay. Okay, now we have the final one, 10 by 23. Who would like to demonstrate that one? Emily?
Here we go. It's 230.
230. And this is the one we all circled, right?
Mhm.
And why did we circle this one?
It's more close to 240.
240. So what is 10 centimeters by 23 centimeters? Give us
230.
230 squared centimeters. How much more do we need to get to 240?
10.
Yeah, so one, we need one
1 10 base.
rod, one, yeah. Okay. So, that's great, we were super close, we just needed one more rod. And we did 3 as we were completing it.
Yeah.
Did we all label the
Yeah.
square centimeters? Okay, now, once we all have labeled our answers to number 3, we're gonna do number 4. Who wants to read number 4 to the class? Yes, Lily?
Ben wants the fire to measure 10 centimeters on one edge. What should the other dimension measure to make a fire that has an area of exactly 240 square centimeters? Show your thinking.
Okay, so now they're giving us the challenge to find 240 square centimeters. What could the other dimensions possibly be? So they give us one dimension. What dimension is that? 10. And then they give us the total, which is 240 square centimeters. Okay, so now I'm gonna give you guys 3 minutes or 2 to show your thinking and find out the answer to this. And remember, the manipulatives are always here if needed. And if you finish number 4 early, you can always challenge yourself and go to number 5. And remember, for number 4, we have to show our thinking. We can't just give an answer, we have to show it. Explain to me what you're doing right now.
Yeah, I just 240 and 100 is 240.
These are 240 plus 10.
Plus 10 times 10. So it's 100. So I add 100. It's 340.
So you did. So you got 340?
Yes.
And what is the problem asking us to do? Do you remember?
Oh, what should the other dimension measure to make a flyer that has a number exactly 200? Okay. So we need to make 240 instead of like just add.
The 240 is the total, right?
Yeah.
Okay. And does a problem give us any other number that could be useful?
10
And what is a 10 in this problem?
10 centimeters on 1 inch. So 24. So it's 240.
So what's your answer?
My answer is 24.
And is there a way you can show your thinking?
Yes.
And then like once you show it, you can try to like show it on your paper as well. And then like label this. Just label, just in case if when I look through your paper, you know what you're thinking. How's it going for your days? Good. I see you have an equation. Is there a way you can show your thinking? Like a picture?
I can do drawings.
Drawings? Okay, drawings is good. I like how we're all trying the challenge problem. That's great. You done? Okay. Could you explain your drawing to me?
Yeah, so it's basically the same but like this. So there's 24 columns and 10 rows. So then the other dimension would have to be 24 if you want it to be 10 because then 10 times 24 would be 24.
Okay. And what would the units be?
30.
What about in our drawing? Could you label the drawing?
Like rocks.
Like the units?
Oh,
Yeah. And just like write how many. Okay, yeah, 10, 24. And then the challenge problem. Wow, you have a lot of possible pairs. That's great. And how do you come up with all of these pairs?
I use like the multiple system. So basically, I know that it ends in a 0. So I know that every number that ends in a 0 can go into 2, 5, 10, and other numbers like for sure. So then I use that to figure out the total amount of numbers, and I also go down the line, so I know 2, 3, 4, 5, 6, all things.
Yeah, that's smart going down the line checking. So these would be all of these are what if 240? They're all it's okay.
I know.
It's okay. Yeah, they're all factors. Good job. Maybe you want to write that down. Say they're all. I don't want your peers to hear you. Okay, so are we all ready? Okay. So I went around and I looked at everyone's question 4 response, and I really liked the drawings that we all had. They're all different, and they were all similar in a way, as we use the same numbers. So we're gonna move on to the challenge, which is number 5. I know that many of you guys worked through it. I just want to ask, what other pairs of dimensions did you guys come up with?
3 times 80.
3 times 80. Okay, so 3 times 80. How would you write that down? Like through dimensions?
3 centimeters
Mhm.
by 80 centimeters.
Yeah, great. Thank you. You have one, Lily?
120 centimeters by 2 centimeters.
120 centimeters by 2 centimeters. Okay, that's also 240. What about you, Daisy? No, you have it? Okay.
Maybe also 4 centimeters by 60 centimeters.
4 by 60. And how did you come up with that like so quickly? I know 60 is like a big number.
It's just automatically.
Automatically?
Yeah.
Okay. Have you thought of one, Daisy? No? Okay. What about, is there a dimension using the side length of 1? Yeah, what would that be?
240.
Yeah, so 240, that'd be 1. So there's a lot of possible other dimensions that we could do, but now we are going to move on. Okay, so we crossed Finn's flyer out. And now we are gonna do the closing learning objectives. So we're gonna revisit them. So throughout this lesson, we were able to solve for the unknown in multiplication and division problems that have no remainders. We were able to use base 10 blocks and array models to see patterns of when multiplying by 10. Before we do the self-check-in, I'm just gonna let you guys know that you can do your thumbs up, thumbs to the side, thumbs down, like right here, and only I will see. So it's okay because I'll be the only one seeing. But okay, so I want you guys to give a thumbs up when you feel good, thumbs to the middle when you're okay, and then thumbs down when you feel like you need a little more help in. So, thumbs. Okay, so the first one would be, I can find the missing number in an equation. I can show area using an array model. Okay. And I can multiply by 10 using an array model. Okay. Now, on one of our sheets, in the back of one of our sheets, we are gonna write one thing you understand and know really well as of today, or as of this lesson and write one question you still have. Okay, so we're all set? Okay. And I just want to go back to the noticing and wonderings really quick. And I'm going to just go back to one of our wonderings. So, what relationship do these equations have? Now that we've done this lesson, what relationship would these equations have?
So if we try to figure out the first one, the answer is 60, and the second one is 6. So the second one, if you like do 10 times 6 is like equal 60. So it's like the first equation. So
Yeah, that's good way of thinking of it. So, and then for y10, why do you think 10 was on here? Yes?
I feel like 10 can help us like solve the problems very quick.
Oh yeah, that's great. And then, yes, Sally?
I think it's also helpful because that's the number that are in rods. There's 10 units in one rod, so I feel like it makes it easier for us to be able to use them.
Yeah, that's also a reason. But do you guys want to know like the biggest reason why we focused on 10 today? Because that was the main goal of our lesson, multiplying by 10. So that's why actually every problem was by 10.
Yeah.
Except we had a few ones that were like, no, they were all by 10. They were all by 10. Well, thank you, 4th graders. Now we can go get lunch. It's time for lunch. Woo! Great job. Now we just have to clean up, but
Very good lesson.
thank you.